simple random samples. And we said that a simple random sample is picking in some kind of random process, either with our table or with our calculator. I showed both of those yesterday. To randomly select people out of the population. And most times we want to sample without replacement, which means that if I'm, if I'm picking, let's say, let's say I want to randomly pick, 2 of these pens or pencils out of the 4, then once I pick the first one, I don't want to just, I don't want to put it back, replace it, and then have to be picking the same one again. That would be sampling with replacement. Sampling without replacement means once I pick one, I've already picked it, I set it to the side, and then I pick out of the ones that are left. And most of the time, if we're taking a sample, we want to sample without replacement, so that each individual picked is a unique individual in the group. So let's say that we have a class that is half male and half female. To get a sample of size 4 from the class, we write the name of each boy on a slip of paper, mix them up, and select 2. And then we're doing the same for the girls. So we're selecting 2 boys and 2 girls. This is not a simple random sample. In a simple random sample, each group of 4 should have an equal chance of being selected. So why isn't that the case here? Why isn't every group of 4 equally likely to be selected here? What groups would it be impossible to have? So I'm picking out of the class. So for example, I could tell you that this second row here would be impossible to be selected, because that would not, this method would not let me have 4 girls or 3 boys and a girl. And so in this case, combinations that are not 2 boys, 2 girls would be impossible to select. So a simple random sample in this case would actually be, I would take all the names of the students and write them on slips of paper, and then I would pick 4 of them at random. The end. That's a simple random sample. If you're categorizing or doing anything further, then you're doing something other than a simple random sample. And so let's take a look at some of those other methods of sampling. So the first type of sample that we'll look at is going to be stratified random sampling. That is a method of sampling which is seeking to reduce the variability of a sample by selecting a sample from each subgroup of the population so that each group is properly represented. So that example that we just looked at, where we pick 2 boys and 2 girls, since there were half boys, half girls in the class, that would be a stratified random sample. Or let's let's say that we wanted to do we wanted to be representative, take a representative sample of everybody in Georgia, let's say. Then we could break down the how much of the population is from which county, and we can make sure to take that proportional of a sample from each county. So if we had 100, if we wanted to take a sample of 100 people, then if 20% of the people were from a certain county, then we could pull 20 people from that county. And then 5 from another if that was 5% of the population, and so on, to make sure that each of the counties were proportionally represented to how many there are. Or we'll look at an example in a minute where we have, if we want to select a certain group amount of freshmen, sophomores, juniors, and seniors, to make sure that they're all represented, either equally represented or represented in proportion to, because there are more freshmen than there are seniors, for example. So we could break down the demographics, whatever demographic we're interested in, to make sure that we're getting a certain amount of people. Now, cluster sampling, so we'll do that in just a second. In cluster sampling, this is a very similar idea, but it's going to be slightly different. Sometimes it's easier to select groups from a population than it is to select individuals themselves. So, for example, if we wanted to survey the freshmen, what we could do is, instead of randomly picking 100 freshmen like out of a hat or something, or assigning each of them a digit and then selecting those digits at random, what we could do is we could randomly select different clusters, different groups, and then pick everybody in that cluster. So, for example, we could take like freshman English classes, randomly pick 3 of the classes, and then just ask our survey to everybody in the class. That's a cluster sample. So, cluster sample is pick a certain amount of groups that we think are similar to the population, and then ask everybody in that group. Stratified is we pick out specific kind of categories or demographics and make sure that we're representing each of those demographics equally. So within strata, we want the strata to be similar to each other in some way. Maybe males versus females, or race and ethnicity makeup, or place that they're from, or age group. And we want to randomly select people within those groups. The clusters, if we're doing cluster sampling, we want those to be as similar to the entire population as possible. So we want within that cluster, we want that cluster to be representative of the whole population, so that we can just ask everybody in that cluster and generalize it to the population. So these are very similar ideas, but slightly different. So let's go back to our example here. My smartboard is glitching out a little bit. We did that. I want to make sure. Oh, let's do this real quick. These are less common, but I want to just make sure that I say something about it. This is systematic sampling. Systematic sampling is a procedure when it's possible to view the population as some sequence. And so this would be, if I had, say, an assembly line, I would take in that assembly line and pick out every fourth item down the line and gather data about every fourth thing. And we would expect that we would hope that would be reflective of the entire population, or like asking every other group. If you look at the data on exit polls, this is usually how exit polls are done for an election, because they will take and pull out every fifth person that comes out of the poll, and then ask them questions about their voting and their demographics and all that kind of stuff. So that's how those are done with this systematic sampling. And then convenience sampling, which we want to avoid, is just doing what is easiest or most convenient. So if I wanted to gather data, let's say, about how people at Dixon High School feel, I could just ask the 5 of you and then treat that as my data. But you are not reflective of the entire population, right? You're all upperclassmen, not an equal balance of males and females, etc. And so convenience sampling is something we would want to avoid. Okay, let's go back to our example here with stratified sampling. So let's say we had a group of 600 freshmen, 500 sophomores, 500 juniors, and 400 seniors. And we want to take a stratified sample of 100. Stratified sample of 100. Well, the total amount of people, 600, 500, 500, and 400. That's 2,000. So we want to know what percent of those are freshmen, sophomores, juniors, and seniors. So freshmen, sophomores, juniors, seniors. Well, out of the 2,000, we have 600 freshmen. So 600 freshmen out of 2,000, that gives me 30%. Sophomores, $500 out of 2,000, that's 25%. Juniors, we have another 500 out of 2,000. That's going to be another 25%. And then seniors, 400 out of 2,000. That's going to be 20%. So we have 30, 25, 25, 20. That means for a stratified sample of 100, we want to use 600 freshmen. Sorry, not 600. We want to use the percentages that are proportional. So we want 30 freshmen, 25 sophomores, 25 juniors, and 20 seniors. So instead of just saying I've got 2,000 people in the school and I'm randomly going to pick 100 of those 2,000 people, we're specifically saying let's take the 600 freshmen and I'm going to randomly choose 30 out of that 600. That's the stratified sampling. Questions on that? All right, I got another example of this, but we're actually going to do it on Friday, at our meeting on Friday. But on Thursday, when you come back on Thursday, we are going to talk about bias and sources of bias and different types of bias. That's what we're going to talk about on Thursday.